So, the last topic in today's lesson is looking at what's called domain restrictions. So, the idea is trying to figure out domain is your x values. So, looking at what are you not allowed to plug in for an x value. And there's two things that can create a domain restriction. One is if you have a denominator. So, if you have a denominator that has a variable, so like this one, a restriction would be that denominator is never allowed to equal zero, because if it is, then it would create a zero in the denominator. The other restriction is when you're working with square roots. You can only work with square roots of numbers that are zero or bigger. We can't take the square root of a negative or we get something imaginary. So here's how you deal with that. I want to kind of show you one of each, and then I want to show you one of each type that you're going to do on Delta Math so you get a chance to actually see an authentic example. So if you are dealing with a denominator issue and you want to make sure that it's never equal to zero, you're going to take that denominator and basically figure out what would make it equal to zero. And then you're going to find the restrictions. So if I set x minus 2 equal to 0, I get x equals 2. So what that tells me is my domain is not allowed to be 2. So there's many ways to write it, but probably the easiest way to write it is you could say that your domain is all real numbers. That's what that symbol means, except x can't be 2. And they will allow you in Delta Math to list exceptions rather than write really big intervals and say it's everything before 2 and it's everything after 2. You actually will be able to choose an option that allows you to say the domain's everything except for this one particular number. Now, if it's a square root, whatever's under the square root needs to be greater than or equal to 0. If it's equal to 0, it's okay. You're allowed to take the square root of 0. If it's greater than 0, great. If it's less than 0, it's a problem. So that's what our domain is. It has to be x plus 3 has to be greater than or equal to 0. And then you can subtract 3 on both sides. So my domain is everything that is greater than or equal to negative 3. Another way to write that, and you can kind of decide if you want to write it like this, I like writing things as intervals, is you can write it as the interval from negative 3 to infinity. And we're putting a bracket around negative 3 because we are including that value. That's perfectly fine. You can put negative 3 into the square root equation. You just can't put anything that's smaller than that. So this is what Delta Math's going to do. They're going to give you the function. They're going to ask you for the domain, and then there's going to be a drop-down menu. And the drop-down menu is going to say, do you want to say the domain is an interval? Do you want to say the domain is everything except one number or everything except for two numbers? So you kind of can choose it based on what the domain is going to be. So I'm going to go kind of clockwise here. I'm going to start in the top left. So this one wants to know the domain. So I have a denominator here. My denominator cannot equal 0. So I'm going to see what makes it equal to 0. I'm going to subtract 12. So I have 4x equals negative 12, and then I'm going to divide by 4. So I get negative 3. That means that my domain is everything except for negative 3. So if you choose this drop-down menu, all values except 1, then you can go in and you can list your exception. And this will say, my domain is everything, all real numbers, except x can't be negative 3. It's probably the fastest domain questions you're going to see. If it has a square root, so the next section you're going to have to do is the ones that have a square root. You need that square root to be greater than or equal to 0. So you're going to solve for x, subtract 14. So we get negative 7x is greater than or equal to negative 14. Divide by negative 7. Now, if you divide by a negative number, you do have to flip your inequality. So my domain is that x has to be less than or equal to 2. So probably the easiest way to do this, the one option that shows up right away is called the interval option. So you're going to say if it's everything that's less than or equal to negative 2, so everything that's this way, you're going to write it, or sorry, not negative 2, positive 2. You're going to write it as negative infinity up until we get to 2, and then you're going to put a bracket around it. So that's how we write that interval, to say that it's going to be everything that's less than or equal to 2. 2 does have a bracket around it because it's included, and it's everything smaller, so we start with negative infinity. So your last type of problem you're going to be given is one that's going to kind of combine both issues. You're going to have a square root, but you're also going to have that square root in the bottom. Now when you have that, now the stuff that's under the square root, not only does it have to be can it not be negative? It also can't be 0, because if I have something that ends up giving me a 0 under there, you would have a 0 in the denominator. So it kind of combines both issues. So when I set up my domain, whatever is under the square root has to be greater than 0. It can't equal 0 because that would create a 0 in the denominator. So we're going to subtract 14. So 7x is greater than negative 14. Divide by 7. So I get x is greater than negative 2. As an interval, now I'm not including negative 2, so I'm not putting a bracket around it. I'm putting a parentheses around it. So my interval goes from -2 to infinity. That's the difference. If it's in the denominator, then we don't include that endpoint compared to the one that wasn't in a denominator. That's really the only difference. So that's the last thing you're going to have to do in the 6-6 lesson is look at different functions and establish the appropriate domain.